Hey everyone, in this video we'll be answering the question, what is a set of real numbers? In order to do that, I'm going to start with the smallest set of numbers that we're familiar with and build out until we get to the real numbers. So the first set of numbers is the natural numbers, which is also referred to as the counting numbers. And that's the set 1, 2, 3, 4, all the way to infinity. Right? They're called the counting numbers because these are the numbers that we'd use to count things. It's abbreviated with a capital N, which can also be written more stylized with 2 bars going across. And that'll be true for all of the abbreviations. I'm not going to write it out each time. Okay, so the smallest set of numbers that we're familiar with is the natural numbers. The next set of numbers is the whole numbers, which is the set of natural numbers and 0. So that's the set 0, 1, 2, 3, 4 to infinity. It's abbreviated with a capital W. And looking at the whole numbers compared to the natural numbers, the whole numbers are larger by 1 number, and that's the number 0. The next set of numbers is the integers, which is the set of whole numbers and their negation. So that's the set looking at what I've written, -3, -2, -1, 0, 1, 2, 3. And this set extends infinitely in both directions, to positive infinity and to negative infinity. Notice that there's only 1 0, right? No positive and negative, because we don't consider 0 to be a signed number. Whereas 1 is a positive number, so its negation would be -1. 2 is a positive number, its negation is -2. And that pattern continues outwards to build the set of integers. It's abbreviated with a capital Z, not what you'd expect, but it's referring to a different language other than English. The next set of numbers is the rational numbers, which is the set of numbers that can be expressed in the form a over b, where a and b are integers and b not equal to 0. So we can think of rational numbers as any number that can be written as a fraction containing only integers. Hey, go a step further. We can write it as the ratio of 2 integers. And that's that word we see right there in rational. Okay, any number that can be written as the ratio of 2 integers. So all of the integers fall into this category, right? The number 4 could be written as 4 over 1, right? -2 could be written as -2 over 1. Some other rational numbers, we would have 1/3, right? Ratio of 2 integers. 0.25, which is 1 over 4, the ratio of 2 integers. 0.1 repeating would be 1 over 9, the ratio of 2 integers. Okay, so repeating decimals do fall into rational numbers because we can express them as the ratio of 2 integers. Whereas an irrational number is a non-terminating, non-repeating decimal. And that's any number that cannot be expressed as a fraction containing only integers. So it can't be written as the ratio of 2 integers. So what we notice is numbers that are rational cannot be irrational. Right? Some examples of irrational numbers that you may be familiar with, pi is a good one. The natural number e, which you may not have seen yet, but that's 2.71818, and it continues on, doesn't repeat, and never terminates. The square root of 2, which we'll look at in a coming video, that's also an irrational number as well. Abbreviation of rational numbers is q. The irrational numbers is q bar. And the reason for that notation is basically you're either in a rational number or you're not. Okay? And if you're not, you're considered an irrational number. And that builds us into the real numbers, which is the set of all rational and irrational numbers. It's abbreviated with a capital R. More commonly, you're going to see that R with 2 bars, so there I will include it. So now, how do these pieces all fit together? So down below you can see a little circle with the capital N in it for the natural numbers. Okay, and then if I click here, the whole numbers come next. Now this is not to scale. This is more to fit the letters that I have written, right? Because technically, the whole numbers is only slightly bigger than the natural numbers. We just added 0 in. Okay, but the natural numbers is inside the whole numbers. That's inside the integers, right? So every whole number is an integer. The numbers outside would be the negations, right? -1, -2, -3, -4. Those are integers, but not whole numbers. Then we have the rational numbers. Okay, so every integer, every whole number, every natural number can be expressed as the ratio of two integers. So it's a rational number. What numbers fall outside of this circle, but inside the rationals? So 1/2, right? That's the ratio of two integers, but it's not an integer, right? 0.25, 1/4, the ratio of two integers, but not an integer. And then if you don't fall into the rationals, if you cannot be expressed as the ratio of two integers, that means, there it is, you're over here, okay, in Q bar, which is the irrational numbers, and then one final click there revealed the real numbers. So everything is inside the set of reals. Okay, so just to give us an idea of how all of these number sets fit together. So now let's look at a few examples. Okay, so we're going to look at the same set of numbers and decide which numbers are elements of the given number set. Okay, so we're going to start with the natural numbers. So which of these are natural numbers? Well, -10, that is not. 6 is a natural number. 0 is not. The square root of 3, not a natural number. Square root of 81, that's 9. 9 is a natural number. 2/3, it's a ratio of two integers, not a natural number. 1.1 repeating, not a natural number. 0.25, not a natural number. And 5.41243, not repeating, not terminating, not a natural number. So out of all these numbers, only 2 fall into the natural numbers, which should make sense. It's the smallest set of numbers that we looked at. So now the whole numbers, well, we should still have 6. We should still have the square root of 81. And the only difference in this one now is we're going to add 0. All the other numbers, not whole numbers, right, by definition. What about rational numbers? Okay, well, -10 is an integer, which can be expressed as the ratio of two integers, right? -10 over 1, so that's good. 6 over 1, that's good. 0 is 0 over 1, right? Ratio of two integers. Square root of 3. Can't express that as the ratio of two integers, so that's out. Square root of 81 is 9. 9 over 1, ratio of two integers. 2/3 is the ratio of two integers. 1.1 repeating, well, that could be expressed as 10 over 9, which is the ratio of two integers. I guess I should have boxed this one in. Same difference. 0.25, as we spoke about earlier, is 1/4. And then 5.41243, not repeating, not terminating, so we cannot express it as the ratio of two integers. All right, but notice now, almost all of them fall into the rational numbers. 2 of them don't. Okay, so these two, square root of 3, that's going to be irrational. Okay, as well as this one. Okay, so now we have a good comparison of the rational numbers versus irrational numbers here. And then finally, which of these numbers are real numbers? And that's going to be all of them. Okay, every single one of these numbers is a real number, because the reals are the set of all rational and irrational numbers. And as we saw in the last slide, we identified the rational numbers and we identified the irrational numbers. Okay, so we didn't do every number set, right? We skipped the integers and we only wrote the irrationals in as the ones that were left out. Okay, but this should give you a good sense of what the different number systems are and how they fit together to create the system of real numbers. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.